tutorialing and learning so I can get up to speed. Because I feel like a lot of these path planners are more C++ than Python.
Yes.
I feel like once I have a better grip on, you know, the basic things that I'm missing, like namespaces, and I guess that's one of the main things I'm missing. Once I have a better grip on that, I think I can further do these path planners properly.
Okay. Okay. My task is to chase down that model for you.
Okay.
Most of them are made off of like a RC car. There's like this one company made a gazebo model from an RC car, and it's amazing. But like that is the base for most of them that I've found.
That's fine. I mean, we don't care at this moment what it is. Like, as long as I can scale it up to more match what the tractor is.
Would be okay.
Would be okay.
Evening, Al. Evening, Lee.
Hey, guys.
Good evening, Matt.
So tonight we don't have a presentation, just an open meeting, and we can kind of talk through different things we're working on. Vinny's on that lattice planner. The only thing we need to do is we need to tune the individual vehicle, and then besides that, we should be able to start using that.
I believe so.
Okay.
What do you mean tune? Do you mean tune the TED planner?
Yes. Yep.
Okay. Yeah, and again, having the simulator actually have the constraints would really help. Right, confirm whether it works. But in order for someone to confirm it on an actual vehicle, I think that's enough to at least give it a shot.
Okay.
To see how far off we are.
Okay, that would be a fun test, right? Drive it around in the simulator, that works okay, and then see how your vehicle responds if it does a similar thing.
Right.
That's on the to-do list. Evening, Alan.
Hey, good evening. How's everybody tonight?
Another day of glory.
All right, fabulous.
I was out spraying the field today. I have a 25-gallon sprayer. It's a pull behind, and I tore the front wheels off of it.
Oh no! Pull the wheels off the sprayer?
Yep.
Oh no!
So, new project. But we're switching to autonomous spraying anyway, and then weed detection. So that old sprayer's got to go. I need a electric one.
That was right. Because the new stuff will always work.
Yeah. You want to give us an update on your project, Alan?
Yeah, maybe later. I gotta get set up here first.
Your slideshow. Al, do you want to give us an update on your project?
Sure, I was just scarfing down a chocolate chip cookie that my daughter had made.
That is awesome.
Hey, you have never tasted a chocolate chip cookie till you tasted one of hers. Let's see. So a little bit of progress. Most of it is a plethora of chatter on Slack channels. So let me just sort of canter through this Slack channel. Share screen and explain the back and forth that took place there. So in this section around Matt's guidance on running this GPS ODOM Pi program, there's a bunch of notes in here, and as a bit of a setup. So I physically have got a lawn tractor, steering under digital control, one sensor on the rear wheel, tracking speed, a GPS that is, talking to a base station. And so it's, although we've not scrutinized the GPS heavily, it's, I'm going to call it decent a GPS signal. So at the moment, the step that in my milestone list, I'm old and forgetful, so I have to have a list of what are the steps that I'm working on, and I'm trying to make that a little bit bigger. Control scroll doesn't seem to be getting the job done.
There's like that percentage next to the print.
Yeah. So Matt mentioned that there's a number of steps in between, testing speed control, and here's what I would love to be able to do is run a 2 waypoint AB line test. So to me, that's like, woohoo, glory days. So I've displayed an ODOM tree. I've got an orphan in my ODOM tree. I'll get back to that in a second. I've got some instructions on testing GPS and getting localization. And so at the moment, this is the step that I'm at. Once hopefully that's done, I'm going to be able to test steering using Ross published steering commands. I have zero idea how to do that, but there's a line item there in this spreadsheet, so that must be what I'm going to do next.
You might have already done that.
Oh, cool. Just like Forrest Gump said, then one less thing to worry about. Forrest, you're rich. I invested in Apple. You never have to worry about money. Good. One less thing. So back to Slack channel. "38 replies. Oh, watch. Is there a way to make this bigger? I don't know how to make this bigger. This is the tree that comes out of the simulator.
You got to scroll down a little bit. That was the first one that you made. That one is a mixture between the Ubiquity and the lawn tractor, but the lawn tractor simulator TF tree is down a little bit right there.
Forget what I said. This is the so this was sort of the goal, right? And be able to get that out of the simulator. And I struggled to get that out, and there's some argy-bargy back and forth about changing some things in the lawn tractor sim launch file. So we made some changes to that, and blah, 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 still some problems, and then voila.
Disco.
Something a little bit better, but this is the orphan. This is base footprint. For those of you who have instant recall, you will have remembered that base footprint was sitting right here. So my challenge at the moment is you know, I don't know how to fix that orphan because it's supposed to be there. And then back to my, if I have completed this, then I need to do that, and I don't know how to do that. So that's where I'm at.
So the base footprint is just a static transform, right?
Yeah.
So why is it? It's a static transform off of ODOM.
Yeah. So base link is your center of your rear axle on an Ackerman vehicle, and the base footprint is the ground. So however far off, Z would be its negative down, but measure the distance between the ground and the center of your back axle, and that's your base footprint. That's where your vehicle touches the ground. And it's a static. It's going to be a couple of inches, 6 inches, or half a foot or something, whatever it is on that vehicle.
So is it static off of ODOM or is it static off of BaseLink?
Static off of BaseLink. It's
Okay.
where it's your robot projection down to the physical ground.
Okay. So why would it be linked up with the map?
It's actually not.
It's just sitting there.
Yeah. Yeah. You don't have to have that. You can drive autonomously just with that TF tree, just like that. You have to have map, you have to have ODOM, you have to have BaseLink and GPS. And so Al has that. If in this state, if he had his robot up and running and the engine was running and he gave it a 2D nav goal in RViz, the robot would try to drive. That's a fully autonomous robot.
Yeah, I'm a little bit nervous about firing off a 22 horsepower motor with this thing sitting up here, to be quite honest.
It just doesn't mean anything. If you want to delete that, it's in the URDF and you can delete that. Or if you want to fix it, you can put a static transform, and there's an example of a static transform in the launch file. But it's not needed. You can drive full autonomous missions around like that, no problem, all day long.
So are you running URDF and use Robot State Publisher? Is that how, since Matt just said that's in your URDF? Typically, I don't do that. I don't have a URDF. I just create links, like static links between the modules to do it, just because I've been too lazy to figure out how to do it right.
Yeah, the URDF, so I do have a URDF file. I mean, in the launch file, let's see if I can get back to it. It's sort of hard to see.
And the reason why ODOM is connected to BaseLink instead of whatever base footprint is because ODOM says connect directly to BaseLink. That's why it connected directly like that. So apparently nothing's talking to base footprint.
This one, let's see, I'm on my Windows machine. What would be the easiest way to show that one to you? Probably going to
That's
GitHub.
not on the GitHub.
Is that here? Let's see.
So the reason why we had base footprint in there is because Stage produces a transform for ODOM to base footprint. And so that's just an artifact that's being carried around. And
so I'm on the GitHub version. Basically what I ran in production is what's on GitHub minus this. This is the URDF that I'm running. And so there was a question about BaseLink. I haven't adjusted any of these settings, so I just stuck with the settings that Matt has, but I will share with you something that we worked on a while ago. Let's see if I can get that up. let's see, what's the best way to get to that?
And I believe base footprint is the new standard. So they have defined that. They say that is your point on the ground. One of the reps said to do that, and I'm not sure which one it was.
Something I'm rather happy that we spent time on, and it was quite some time ago. Look at that, December 5th. We have
2018, December 5th.
Yeah, it goes way back. I was a little bit, but it just hurt my brain figuring out these joint settings and these origin statements. So there's a long video that we've posted that Sam helped and Matt helped. And I basically sort of listened to them about a zillion times and then backed into a bit of an algorithm on how to calculate these. So effectively, if you take 4 measurements about where things are and your wheels and your GPS and whatnot, this little spreadsheet will help you calculate that argument statement. So anyway, if you watch that video, you mess around with this spreadsheet, you'll have a better understanding of those arguments and how they're calculated. Some of that's also explained in this list of 38 replies. And this will be the last thing that I yap on about, and then somebody else can talk. In this document that's also out on the Google Drive, is sort of my tortured path to get to where I've gotten to so far on this. And I'm just trying to get down to the video section because the video is an hour and a half long. And where did I put those? Oh, here we go. So I have not adjusted the origin statements yet.
Can you make that bigger?
Yeah. So if you go watch Sam's video, he goes into great detail about, sort of the theory and the behind the scenes on setting these things. And I've just explained, this is the line and here's the video and there's the where in the video to look at. Thought I had the time reference. Oh yeah. Go to minute 47 to talk about line 21 and 76, and the first 46 minutes talk about line 10. Sorry about that, but it's a long video.
Can you post the link to that video?
Sure. And again, it's in these. So anyway, that's painful, but partial progress. So if Vinny, you got some magic navigation code to test, man, all over it. Just bring her on, baby.
I mean, I think it is ready to test, but I don't know.
You got to make it easy for me. So I'm like, give me a waypoint, or I gotta know how to test it.
Sure. I guess on your list you don't. Where are you on your list? Because you were missing a few steps, right?
Yeah, well, I'm happy to tell you what's on my list. Hold on a second. There were some open spaces on the list because Matt said there were 27 steps that I didn't have on my list. So let's see. And I didn't know what those 27 steps were. I think he was joking. I'm hoping he was joking, but. So I'm somewhere in this space. Definitely done that. Definitely done that. I haven't done that. Matt thinks I've done that, but I didn't know it. And I sort of got that.
What does it mean by test steering? I mean, it seems like you send it to command velocity. You can turn left, you can turn right.
Yeah,
What's
okay.
a steering command?
Can you turn left and turn right using ROS?
I can send a teleop command velocity, yes. But I can't say, I can't issue a ROS command that says, turn to a heading of 270 degrees.
You can. It's called a move-based goal.
There you go.
And you have that you can do that now.
And your architecture is close to what the simulator is running now?
I only have the simulator architecture.
Okay, so you have the same architecture for the simulator. Okay. So I think you can test the latest path planning. And basically what you do is you'd load it up and you'd send it a goal using RViz, and you can see what it does. And I'm assuming you have an e-stop.
I have 2 or 3 e-stops, yes.
Okay. Yeah, I think you can load up the most recent one on the repo, and you can try it out. There might be a few dependencies that you don't have that you'll need to install.
Cool.
But yeah. If you need anything from me, just let me know.
Instructions for, those books that say, like Python for Dummies and ROS for Dummies. That would be Navigation for Dummies. Those are the kind of books that I buy.
Okay. Like, do you want like me to write up a small step-by-step?
That'd be super. And I promise that I will add to it whatever I have to figure out. I will embellish it or make it easier for the next guy.
Okay. And that Google Drive, is that open to everyone that you're referencing?
As far as I know, it is. Matt?
Yeah.
I think I've lost track of it.
In your welcome packet, welcome to ROS Agriculture. Can't believe you don't have your welcome packet.
Because I'll see kind of what you already can accomplish, and like what kind of networking and VPN and so on.
I mean, I am running the VPN. I mean, it's been a bit of a journey to get to this point.
Right, and I'm going to catch up to where you are to understand your setup, basically. Yeah, I'll try to get you something this week.
Cool, thank you.
It's awesome. Good job, Al.
Now, I don't have something physically that I haven't implemented yet, as I only have a speed sensor on the left wheel, so I've got a few more hours of work to get the speed sensor organized on the right wheel. I don't know if that's a critical input or not.
I don't think the simulator has speed sensors on the wheels. Does it, Matt? Do you know?
No, the simulator doesn't.
It's just on pure GPS.
Yeah, and there's no air, you know. Yeah, exactly. Yeah.
And before Alan goes, I'll tell you what I did. I took that little ESP module. I did get it to compile finally, or I got it loaded onto that board, and it does work, but I'm stuck with running everything through that little USB port that's on it, and I cannot figure out the UARTs. That they allude to the fact that maybe you can change them, maybe you can't. I tried looking at the source code. I can make no sense of it. But if somebody can figure out how to change the UARTs on that would be just be a handy little general purpose board to, you hook it up to a serial port on one side and it talks over Wi-Fi on the other side. So that would be real handy if somebody knows how to program that stuff. It's based on something called ESP-INF or something. It's the actual development system from the EPRESSIF, whatever the company is that makes the chip. And I went so far, I thought, well, here it's talking about initializing UARTs, initializing pins. I'd searched for it and couldn't find it, so I thought, well, it's either some kind of object-oriented stuff or it's in whatever their development system is. And sure enough, in the development system, that's where that stuff is. And I still can't figure out what they're doing. So anyway, that's a replacement. He bought the little board to plug into his F9P board. I think they want like $74 for that board, and you can replace it with, say, a $5 to $10 board if somebody ever figures out how to make this change. But I can't do it, so I've pretty much given up on it.
Was that using it in relation to that TNC board?
No, this is just one of those ESP32 modules that was put onto a board that'll plug into like an XB socket. That's a custom thing that a guy made.
Okay.
And then he says right in there with just slight changes, it'll run on a regular ESP32 that you can buy anywhere. And I had one laying around, so I tried it, and that does work. And then it's also got the Ntrip client, the Ntrip server built right into it, or you can set it to raw mode, just TCP/IP. So if you just want to take the raw correction data out of, say, one of your GPS modules, send it over Wi-Fi or something else, and just load it back in there, you can do that as opposed to the Ntrip type stuff. But I can't figure it out, so. That's all I got.
Thanks for looking into that. It looks like a pretty cool solution. Alan's upgrading the place. We all gotta keep up with Alan now.
Yeah. He's underneath the stairs. Harry Potter.
Yeah, that's the attic, actually. Yeah, well, thanks for everybody's help this last week here. I think, Jeff, you helped a bunch this past week, and Al, you helped a little bit. So I'm still waiting for ArduSimple to get back to me. I kind of locked up my base station, did the firmware upgrade. They said I could use that to get out of the lock situation. A couple other things that I tested, and so I finally was able to get the logs out of it and did a core dump out of it and sent that off to them. So I'm kind of waiting to see what they come back with. So I can get to the device at a very basic level, but it won't work with my USB. When I try to connect uCenter to it, it just says can't connect. And so it's kind of strange. I don't know what's happening. They're suggesting that I maybe overloaded it with too many messages, but I didn't really know how to set up any messages. So I really just left it with the default number of messages that had previously been going over my USB. And I guess when they tried to send the same amount of messages over Wi-Fi, it overwhelmed the system somehow and locked it up. So not entirely sure. So we're going to have a session with them to try to get that squared away. So that's my GPS journey. And I did have it working to the point where I had, I let it run for a while, not a super long time, but maybe half an hour. And the min to max range was about 10 centimeters. And most of the data points were within a couple centimeters. So it looks promising. It's just, I got to get it fully the way I want to. And then I did have it running with the Ross Agriculture, the GitHub, I don't know how you say it. Is it NMEA? There's a NavSat. Anyway, that code, I did have it running with that for a while too. So that was good to see. And then let me show you. Yeah, go ahead.
I don't know what the official name is, but I've always heard it as NEMA.
NEMA.
Oh, yeah.
So that's that. And then let me share my screen. So we have updated in RViz. First here, we have the arm is now attached to the rover. And there's a few things we need to fix on this yet. A few of the, like this arm will run into this frame if I rotate that. You can see it kind of goes right through the frame. So we've got a few things like that we got to work on. And I don't know if I like the way that this is positioned, but to me, this is one of the advantages of simulation is you can see what it looks like when it starts to move all together as one unit. Right now I've got the physical arm separated from the rover. The rover's out in the barn and the arm is right behind me here. So I actually have, can you see that? This is what the physical arm looks like. This is, actually I have two of them. This is one, and then the second one is basically the same, except I have one extra 3D printed part up here at the top. So you can see, you got two arms. They're almost exactly the same. And if I don't have it hooked up to run, but I have that code still in Java to run these arms, so I got to get that over to Ross. But the idea being when I control one arm manually, so I'll be able to position this arm where I want it to, then the second arm will go to the exact same position. So it'll be a mirror image or an exact copy of the arm. So I'll have one arm at my control station, wherever that might be. And then I'll have the other arm on the rover, say out in the field somewhere, and I'll be able to control it multiple different ways. But one way will be to control the arm itself. So I can just move this where I want to, and the other arm will follow the same exact position. And then I'll also get it set up probably for keyboard control and gamepad. So I got a gamepad. And we'll probably use your code. I think there's some code out there that the teleop, or not teleop, but code that we walked through last week and use that. So I have a couple different ways to run the arm. But for right now, we're just starting in the simulation in RViz. And probably by tomorrow or the next day, we'll have it in Gazebo as well. So that's kind of the update that I've got for today.
So the rover model that you created, are you putting it out somewhere, or is that kind of yours?
I haven't put it out there. I guess I could.
Because if you do, I'd love to take a look at it, because I think that would help me in my quest in creating the Ackerman constrained tractor in Gazebo.
Yeah, and what, you know, in the physical, in the actual rover, and, you know, I don't have a link. There's not a physical link that goes between the two front, you know, steering mechanisms. They're
Sure.
completely servo motor driven on each side, and then I just, you know, set the angles accordingly. So I don't have a physical, you know, I'm not driving both with one servo, but the same concept, the same angles apply. You have to have the same angles, whether there's a linkage in here or not, in order to have good turns.
Right. So your real robot will also just have 2 individual servos per.
Correct.
Okay.
Correct.
That's
Yep.
cool. Yeah. So if you don't mind sharing that with the group, I think that would be a good base model for me to work off of.
Okay. Yeah. One thing, actually, just to get into the details a little bit here, it's actually backwards right now. This extra frame right here is where we were going to put the generator motor. You know, the motor, the gas powered generator would sit inside of this frame. That's supposed to be on the back. Anyway, it's kind of turned around here, but rather than try to get that fixed, that was minutia in my mind. I just was happy to see the rest of it. So, but things like that we'll have to fix as we get a little bit further along into it.
How are you controlling the steering on the wheels right now? It looks like your little sliders, you have one for the left and one for the right. Are they totally independent right now, or do you have one that says set steering and it calculates?
Yeah, in RViz, they're completely separate. In the Gazebo model, and I showed that last week, the Gazebo model has them so that you just have one control for both. And then they turn according to so they get to their proper positions.
Okay.
So that's all I had. I'll stop sharing unless anybody else has a question. So Vinny, come back and ask me to make sure I put this stuff out there. I probably won't get it out there in the next week or two, but we'll head that direction.
In the physical
Sure.
world, what's going to move those wheels? You probably maybe have covered it in a previous meeting and I just missed it. What size motors are going to move those wheels?
Well, let's see. I don't remember off the top of my head. Let me look here.
They're DC motors, and you'll have some sort of chain or something coming down to.
Yeah, there's a gear, actually, that doesn't show it in the diagram here, but there's a gearbox up here, and then the motors are up higher and run at an angle.
And is that something you've designed, or is that a purchased kit kind of thing that you've got?
No, it's a start from scratch. It's a hack from scratch. I
Is it
think
professional in the design that you've got here? The reason
Yeah. Go ahead. Sorry.
I was going to say the reason I'm wondering is I have aspirations someday of moving stuff around the field, and it would just be. I'm just curious about your propulsion system there.
Yeah, I don't remember on the steering. It's one of these two, either the 23-1 or 47-1. I'd have to go look to figure out which one it is. So it's a 102 kilogram per centimeter of torque, 82 RPM.
And total mass of that whole robot, what would you guess the weight of that whole thing is going to be?
Somewhere between 75 and 90 pounds.
Okay, cool.
Yeah, I had used smaller servo motors with less of a gearing system the first iteration, and that wasn't strong enough, so I had to go back and add. I've got it. It's working pretty well now.
Well, it's not a big jump in my mind from 80 pounds to 8,000 pounds, so.
That looks great, Alan. Good progress.
Me, because I see all of that and I'm like, oh my gosh, every layer of that is so much. You pull up those arms, like, oh, look at all of those joints. Oh, every one of those parts that need to be modeled and dimensioned.
Well, the number of 3D prints per joint, I think I printed each one at least 5 different times before I got to something that I liked, right? You kind of do the minimum viable product approach, right? Something that'll work, and then you put it on there, and one of them got too close to the wires, and so I had to, I would have cut the wires off had I actually used it. So I had to, redesign it to get the wires to stay safe when it was moving, and different things like that.
I know that pain.
And then are you going to build this same scale vector? What's this for?
Well, the idea is that it would go out in a vegetable field, and I could, in order to stay organic, I don't want to spray chemicals. I want to maybe do some flame weeding. So put a flame at the end of the rover arm, possibly some mechanical weeding, things like that. Certainly use it for observation, so visual observation. We can get very close-up shots of what's going on, so you can see insects and insect eggs and things like that, in addition to the weed pressures. And we'll be able to record the data, the visual data, so we can see what the plants look like week to week to week, things like that. And then, longer term, of course, would be to do some things, harvesting, and probably start out, like I was showing some manual moving of the arm and stuff like that, but try to figure out how to automate some more of that.
Cool.
Lee, how's your project going?
Oh, hi, Matt. Just to get the motor control sold. So I used to complain a lot, like the parts made in China. But after I saw this motor control, I think totally 69 weighting points, then I don't have much to complain. It's really hard to solve them one by one, actually, So I get everything set up right now, but I have trouble like to install the. I installed the Ubuntu core before, but right now I have trouble to log in again, back again. I guess because of the user key to log in instead of the username and the password. I forgot that. The problem is that. So what's your suggestion? Like I stick to the Ubuntu core, or I can like install the maybe the normal ROS, you know, Ubuntu ROS system. Maybe that's another way to work around because I could not get it through right now. Yeah.
Yeah, the Ubuntu core is kind of interesting in the sense of the security layers on that. It's kind of interesting to learn that process, but it is kind of a pain. If you lose your key, you can't get into your computer.
Right.
I mean, what you have to do is you have to log into your Ubuntu account. You have to upload a new public key, and then you can use that key to log in. But I had a problem like that before, and I just redid it. I had to load Flash again and go. But yeah, Jeff posted a link to a download page for the Ubiquity Robotics, and they make awesome robots and a really cool Raspberry Pi image. So,
so you recommend to try that?
Yeah, I think their robots are cool, and their image is really nice. The Ubuntu core is kind of a cool way. It's definitely more secure, and it teaches you some principles and that are interesting. And I would still go through that guy's tutorials on how to write ROS nodes, because he is very clean, and there's good stuff there. And you get to, at the end, you get to drive your robot around. Did you get a joystick too? Did you get one of those?
I get a joystick not yet, but they said they shipped it to the US like last Friday. So I'm still waiting for it to deliver to my home. Yeah.
You can still drive it around with a keyboard or by typing in ROS commands, but it is kind of fun to get the joystick working to learn that process. It's neat.
Sure.
Hey, did you get a camera too for your Raspberry Pi? A V2
The camera?
Yeah.
I have the Raspberry Pi camera.
Okay. Wow. Okay. Then you can run fully autonomous missions. Look out, Lee.
Yeah. 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 Actually, a lot of questions when I think what you are going to test when this program. So I'm thinking about, so two questions actually. One question that this kind of simple, like two-wheel driving, like, this toy car, doesn't have much people simulate on that. I'm curious because many people is widely used, right? So I'm wondering any modeling like in Gazeba or simulation model for that. The second question is that, so instead of trying this kind of field robots, is that possible like to try the program such like a toy car instead? I mean, like you get this kind of two story, like two layer, like forward, I got a forward chassis. I would say four wheel chassis, 2 story, 2 layers. So it still can carry some sensor. So I was just wondering why we not try the program such a toy car instead of the actual, big robots. So any kind of consideration for this?
Sex appeal. I mean, really, Lee, you can put wheel encoders. Like I have wheel encoders for my little robot. I was trying to find them so I could show you. You can do so much with that little robot that is exactly like a big robot. It's mind blowing. Like if okay, so you're talking about the differential drive. That's a very common platform in Gazebo. Tons of simulators for that. You can just use like a little Roomba, it's a TurtleBot is basically the learning platform for ROS is TurtleBot. And this is just a cheaper version of TurtleBot. It doesn't have a laser, doesn't have other things. I wouldn't mess with the laser. I would go with camera. You can do a ton of stuff, cool stuff with a camera, and you'll use that outside as well.
Yeah, so my question is that if, let's say, if we let the toy car also carry a GPS, so mostly you said we can test almost all of the functions, right? Like visual, navigation, video or down, almost every function can be tested then, right?
Totally. Exactly. And you will sort of have a GPS-like sensor in the sense if depends on how you use your camera, but it can give you an absolute position. But don't worry about the differences between the GPS on the outside world yet. That's just localization. It just tells you where your robot is. And for example, like on mine, I just put an AR tag on my robot and then have a camera pointing down on it. And so the camera tells me where my robot is as I'm moving through the scene. That's exactly what your GPS does. It tells you where you are absolute in an environment. So you'll be okay.
Matt, you keep on using the word just.
What's that, just?
Just. You just know where your robot is. Well,
I
think we talked about this before. It's probably the hardest thing.
Yeah. Exactly. Yes.
So your point is that so basically the program can be tested on this toy car platform basically.
Totally, all of it. Mind-boggling that the exact same code will run on a big tractor with the exact same Raspberry Pi will run on a big tractor. It makes no difference. The robot software doesn't know, doesn't care. MoveBase doesn't care. It just runs. That's what's kind of cool. There are some little things that are less fun, but having an inside robot is helpful. It's not as cool as having an outside tractor, 12,000 pounds running around, but you know.
Yeah, I mean, if not talking about the agricultural field, I mean, this toy car also can run outside, right? Like the concrete or parking lot or concrete road.
Exactly, and you can put a GPS on it then.
Yeah, actually I had a 3DR, like this very low resolution GPS.
Yeah, you want to if you want to port that 3DR GPS IMU combo out of ArduPilot into ROS, yes, please do that. They're like a $30 GPS IMU package, and they do a really good job. I haven't. Maybe it's already done. I just haven't heard about it or found it yet.
You mean what kind of IMU package? So
the 3DR GPS IMU.
You said that's $30?
Maybe 60. I don't know. I'm making it up, but it's not 600 or 300. It's under 100. And there's a ton of them out there. People put them on drones everywhere. And the ArduPilot software is open source and ROS is open source. We just need to get their localization algorithm from ArduPilot and get that as a ROS node.
Oh, so yeah, it should be Is that not available still?
Go for it. Sign up for that task, Lee. Come on.
I mean,
All you got to do is copy that algorithm, however they do that, and paste it into your ROS node. See how simple that could be.
Just
not kidding.
I think this is how you advertise all your projects, Matt. That's how you advertise with Pathway.
It's simple. It's copy
So-
and paste.
So the question that you want to use that autopilot is autopilot system, right? Is that your purpose?
Just the localization algorithm.
Autopilot is a very big program as far as I know.
Yeah, all you need is that one page that has the localization algorithm. Not the whole thing. We just want that.
He's pulling your leg, Lee.
I mean, I really want it. We could create a bounty and put it out there. Maybe we could have a hackathon.
I think I heard
Yeah.
400,000 lines of code in ArduPilot.
Yeah.
And I think I've looked through 200,000 of them.
Well, I think probably, Matt, you can draft a one-page summary of the question and maybe the expectations.
Okay. Put it out there and see. Can't hurt.
Yeah, must be somebody interested. If we could not do it, I mean, we can try at least. Yeah.
Thanks for your update.
Just real quick, is that the GPS you're talking about?
There's like tons of knockoffs. Exactly. There's an IMU and a GPS in there. $40. Okay, $45. It's pretty good.
That's pretty good. I might buy this.
And their
just sit on
algorithm that they use in ArduPilot is solid.
I guess do I need the Pixhawk to use it?
If you get the flying leads, that has a connector, but you could just cut it. But the Pixhawk has the connectors that match those, but you can just cut them. You have flying leads, and then it's just the data coming across there. I2C for the
It's
IMU,
I2C.
and then serial for the GPS. Vinny likes
This-
localization.
Hmm.
Oh, okay.
All right.
we're at-
Looks I have the exactly GPS.
Yeah, I have one there.
So you mean the IMU was built in already?
Yes.
Oh,
On the
okay.
one that I have, I don't know if that one says it.
It has a compass. I don't know if that means the same thing as an IMU.
Okay, well that's where they're getting their heading from. Okay. Okay. Yeah, because it's a full package. You get your heading and you get your location. Is there anything else for tonight's meeting?
I got my diesel drained out of my lawnmower this weekend and gave it an endoscopy with yeah, Jeff, I have one of those. The one I have is basically the same as yours. It's not like close focus. Anyways, I got one of those endoscopes that you can use on your pipes. I stuck that down the gas tank, and it appears to be a stick down there, but I don't know where my little grabber thing is that, to reach down there and get a grabber. And so I'll have to go get another one so I can get down there. And I guess stick is probably plugging up that gas line. That's why it's dying on me. And I went ahead and I ordered that O-Drive, Jeff, that you had talked about. It looks like they're working on a ROS node for it, but it's supposed to integrate with the Raspberry Pi, and there's some libraries for ROS for it. And as a backup, I ordered a couple of identical electrical 36 volt, 48 volt, 350 watt bicycle motor controllers and see how well that works. One thing with the O-Drive, you can run two motors off the same board. Which was pretty nice for like, I saw a example there. You had a girl in a shopping cart and driving it around and using the two motors, using the system. The little video on their website, I thought was kind of cool. That's where I'm at.
So I have 2 comments. Doug, you could make a little robot to drop into your gas tank and go pick up those sticks.
Sure.
And the other thing was, back to that Ubiquity image, I did download that and it would not burn to a flash card on my Linux machine for whatever reason. Moved it over to a Windows machine and it did burn it there. I stuck it on my 4 gigabyte Raspberry Pi 4 and it does boot up, gives me a desktop. And this version actually has like a Catkin workspace already predefined, which some of the older ones didn't have that. So it may be something ready to go if you get that far. I don't know if the previous version was at that level, but all the previous ones would not run on Raspberry Pi 4. So as far as I know, this is the first one that will just load up and run. And then the other thing, speaking of Raspberry Pi 4, I think if you go look at the GPIO pins, it's enough better processor. I think it's now got like multiple UARTs out there, and it's got various other functions that the older ones didn't have. So it may be interesting to switch to that board to get better peripherals, or I wanted it because it's faster than the older ones. And I keep telling people it's faster than the Jetson Nano, but everybody argues with me on that. And the other thing is you can now buy it with either 1 or 2 or 4 gigabytes of RAM. If you start doing large maps, you really would like to have that extra RAM there to play with. So whether or not it's worth buying that and going to, I think they want $55 for the 4 gigabyte one. So you can temper that with everything else. So theoretically, I could just dump both the one I got and both the Raspberry Pi 4 into the same spot. But then I have to go through and redo all my software to make sure I've got everything up and running. So it'd just be a matter of copying it across, I guess. So that's all the farther one. I booted it up, got the desktop, and played with it for a couple of minutes, and then shut it back down. That's all I've done with it.
Okay. Thanks for testing that out. That'll be neat to see.
Well, the other thing I didn't try, I didn't go out and do an apt-get package to see if everything that's compiled will actually just load and run on the Pi 4. That's something I really should have tried. So I could have just grabbed a random package that they don't have on there and see if that, number one, doesn't find it, because it goes out and says, what kind of processor do you have? And it goes out the list and tries to download this stuff. So it'd be interesting to see if it finds it, and then once it's there, if it actually runs without complaining about anything. But I didn't think of that at the time, so I can go back and try that someday.
Okay.
But the power supply is a pain, right, Jeff? Like for the Raspberry Pi 4, it requires much higher voltage amperes.
It's somewhat higher, but the big deal is they switch from a USB micro connector to a USB-C, so it's a different physical connector. So if you buy it and you're going to run it on your desk, they'll sell you for $10 another power supply that will plug directly into that. And the other thing is you can actually power it on the GPIO pins. If you tie to the 5 volts there, you can actually power it with some other 5-volt supply. So there's a couple of ways to do that. You could just buy a USB-C USB cable to cut it off and then hook that up to your power supply. That'd be another way. Or if you get a regular USB to the USB-C, then you got a regular USB connector you can plug into something to power it that way. But yeah, I think it does take more current than the previous board. And if you get one of those, keep in mind it's also got the micro HDMI connectors. It'll support 2 displays, but they're the micro connectors. So you have to go out and buy a cable that's a micro to a normal HDMI to plug it into your monitors if you want to do that. And I was trying to think, there's probably a couple other things that you get it and think, oh, I can't run it now because I don't have the right pieces to make it go, but I can't remember what they were. my biggest problem was I didn't know where my cable was. That was the HDMI to micro HDMI. I dug around and I found, in fact, here it is right here. I found this little adapter that's a T. So it's got a micro connector on this end and a mini connector on this end. And then it's got the regular HDMI like that. But that wouldn't plug into my, see what was it? Oh, so when I went to plug in the board, I plugged it in here, but then this was in the way of my power connector. So I couldn't use this. So I had to dig for a couple more hours till I found my cable that's just a straight cable that plugs in with a micro HDMI. So all these little things, you try it and think, oh, I got everything I need, and you try it. Well, it doesn't fit or doesn't work or whatever. So, you know, it's still some playing around to get all this stuff to work.
Awesome. Thanks for that update. Thanks for being here tonight, and we'll call it in, and hope you guys have a productive robot week.
Night.
Yeah.
Good night.
Yes.
Thanks, everybody.
Bye.